In section 1.3, we're going to identify some of the properties of and changes in matter as either physical or chemical changes. And we're going to identify the properties of matter as either extensive or intensive. So properties are the characteristics that enable us to distinguish one substance from another. Matter has both physical properties and chemical properties. Each element and compound has its own unique properties. Though sometimes they may seem really similar to one another, and so it can be kind of difficult to tell them apart when they're really similar, but they are unique, and if we can measure them with enough accuracy, we can tell the difference. Understanding the properties of mixtures, components, is essential to successfully separating them. So physical property is a characteristic of matter that is not associated with a change in its chemical composition. Examples of this could be density, color, hardness, the melting or boiling points that they have, and their electrical conductivity. These are all physical properties, and there's not going to be any change in its chemical composition, i.e. no chemical bonds are going to be broken or formed when any of these change. So a physical change is a change in the state or properties of matter without any accompanying change in its chemical composition. An example of this would be like phase change. So like if you have solid butter and you melt it into a liquid, then that is a physical change. We haven't changed that it's still butter. We just changed what state it's in. And another example would be like steam that condenses up here. So it was water vapor and it condenses down into water liquid on the top of the lid, but it's still water. Chemical properties. These are the change of one type of matter into another type, or the inability to change. And this is an example of chemical properties. Some other examples are flammability, toxicity, acidity, reactivity, and the heat of combustion. So our examples here is that if you have steel or iron and you leave it open into the air, it'll eventually rust. But chromium does not actually rust, and that's why we wind up coating a lot of metal parts in it to protect them from rusting. So this shiny stuff you see on like motorcycles or cars and stuff, it's actually a layer of chromium metal over the steel. Here's some examples of other examples of chemical changes. Here we have some copper that's dissolving in nitric acid. When that happens, the copper forms copper nitrate, which is this blue solution here. And it evolves out this brownish gas that is nitrogen oxide. Here you can see that like the phosphorus on the tip of a match has ignited and it's now burning through the wood. So burning is a chemical process. It's a chemical process when you cook meat that changes it from the initial like red-pink color, which is like myoglobin in the blood of the meat, to that brown color that you see later. That's the oxidation of that myoglobin. And the same can happen with fruit, with like say bananas. You have oxidation of this outer material here that leads to those little brown spots and stuff. And there's still a chemical process that's happening on the inside where enzymes are actually starting to break down some of the complex carbohydrates into simple sugars, which is why they start to get sweeter. So this diamond you're going to see on bottles for chemicals and on other signage that indicates hazards. And it's important to kind of understand at least the broad strokes of what this is about. So over here in the blue, these are going to be your health hazards. Typically, like how toxic is it? Maybe it could be a carcinogen or something. That's going to be indicated by this number here. Red is how much of a fire hazard it is, how flammable it is. And yellow is going to indicate its reactivity. And often this can indicate whether or not it's going to spontaneously catch fire or explode or something like that. And you can see the various values and what they mean, but in general, the larger these numbers are, the more dangerous it is. For instance, a 4 over here in reactivity means that it may just detonate and explode. And then you're going to have specific hazards are going to be indicated by symbols down here. Okay. For instance, this W with a cross through it means you can't mix it with water. It may explode if you do that, right? And then you have oxidizers, whether it's an acid, whether it's a base, corrosive, and even if it's radioactive. Those are all things that can be indicated by this bottom one down here. In particular, you want to be very careful with anything that has a 2 or a 3 or higher here. There's actually even another one up here, the level 5, and level 5 requires very careful consideration when you're going to use it in any kind of laboratory. Okay, extensive versus intensive properties. So extensive properties depends on the amount of matter that is present. Okay, so this property is going to change when you have a larger system. You have more of something. Okay, so examples of that would be mass, volume, or heat. Right, so if I double the amount of sugar I have, then I'm going to double its mass, right? And it's going to occupy more volume, right? And say if I have something that's producing heat, like a fire or something like that, if I have more fire, I'm going to produce more heat. Now, intensive properties do not depend on the amount of matter that is present. So this is things like density and temperature, right? If I have sugar in a glass and I add more sugar to it, I'm not going to change its density. It's going to have the same density because the mass and the volume both increased to maintain the same density. And temperature, right? If you are inside of a house and you have a certain temperature and then you close the door to a room, well, now you're in a smaller system, but the temperature still remains the same. One important thing to note is that the periodic table is actually laid out according to certain properties. And this is found most often in the columns here. So each one of the groups or columns are going to have similar properties. So down here, you're going to see all these have similar properties. Here, these guys have similar properties. Similarly, as you go down, and you may even be able to kind of recognize this as you look at them. For instance, copper, silver, and then gold all have similar properties. They're all shiny metals, right, that are very malleable. Similarly, you have nickel, palladium, and platinum. They're all shiny metals that actually look quite similar to each other, like kind of silvery and stuff. And then that's kind of true as you go down most of these columns, although you do see some break, like for instance here where you have the metalloids and stuff. These ones down here are kind of similar to each other, and these ones up here are going to be similar to each other, but not necessarily across these this boundary right here.